Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Hi everybody, how are you today? Hoping you that are in a good conditions. Um, okay, today class we will continue about air conditioning, still in chapter 6. And before I go further on this chapter, Uh, I would like to make an acknowledgement and also to thanks to Dr. Azmi Hussein uh, for his efforts to produce these nice slide presentations for me to use and discuss with all of you. Okay, today class we will continue about air conditioning and the objective that you must know or you have to or you have to obtain the objective for today is number one. Student, you should able to relate the adiabatic saturations temperature and wet bulb temperatures of atmosphere air. Number two, you must also can use the psychrometric chart as a tool to determine the properties of atmospheric air. Okay, this for today class is only two objectives. Uh, you have to get or obtain. Okay. So I go. I will show you today's slide. Okay, it is about adiabatic saturations. Actually, adiabatic saturations is another way for you to determine the absolute or relative humidity is related to an adiabatic saturation process. As you see in the pictures or figures here, okay, this is the device that can be used to calculate or determine the relative humidity. And at the right side is the TS diagram, show the as a technical how it happened when you want to determine the relative humidity. This system consists of a long isolated channel that contain a pool of water. The steady stream of unsaturated air that has a specific humidity of omega 1, okay, here, and a temperature of T1 is passed through this channel. As the air flows over the water, some water evaporates and mix with the airstream. The moisture content of the air increases during this process, and its temperature decrease since part of the latent heat of evaporation of the water that evaporates comes from the air. So if this channel is long enough, the air stream exists as saturated air. That means phi is equals to 100%. Okay, here at the temperature T2, which is called as adiabatic saturation temperature. So if make up water is applied to the channel at the rate of evaporations at temperature T2, the adiabatic saturation process described in here can be analyzed as a steady flow process. This process actually involves no heat and work interactions, and we assume that the kinetic and potential energy changes can be neglected, okay, for this device. So when if you see in here, we can apply the conservations of mass of we can apply the conservation of mass and conservations of energy equations related to these two inlet and also one exit steady flow system reduced to the following next slide. Okay, let I show the next slide. Okay, based on the mass balance, the mass flow rate of the dry air remain constant. That means m dot a dry at point number 1 is equals to m dot dry at point number 2 is equal also m dot air at point number 3. So based on the mass flow rate of vapor in the air increases by the amount of energy to the rate of evaporation. Okay, so m dot water vapor at state 1 or point 1 plus m dot f is equals to m dot 2 at water vapor, or we can simplify these equations will become m dot a omega 1 plus m dot f equals to m dot a omega 2. And then we simplify all the equations, it will become n dot f is equals to m dot a times omega 2 minus omega 1. Okay, this is a formula you can use when you want to find m dot f. Okay, for the adiabatic saturations temperature. Okay, let's look on the energy balance. This is a steady flow process. So the energy balance in is equals to energy balance out. Okay, remember you're in the course of thermodynamics 1. So for energy, the rate of energy in, that's mean m dot a time enthalpy 1 plus m dot f hf2 is equals to m dot a h2. And we can, and then, or we can put n dot f that has been defined previously to these equations, and it will become m dot a h1 plus m dot a the differentials of omega time hf2, and this is equals to m dot a h2. H is enthalpy at point number 2. So by dividing these equations by m dot a, then lastly the equations will become omega 1 is equals to Cp T2 plus T1 plus omega 2 HFG2 over HG1 minus HF2, where omega 2 has been defined in previous lecture, okay, where phi is equals to 100%. Okay, that's mean adiabatic saturation. So omega 2 is at temperature at state of point number 2. Okay, when you refer to the adiabatic saturation temperature device. If the air entering the channel is already saturated, then the adiabatic saturation temperature, that means T2, will be identical to the inlet temperature T1, in which the equations that I have defined here will become omega 1 is equals to omega 2, right? So in general, the adiabatic saturation temperature is between the inlet and a dew point temperature. So there is another more practical approach, okay, of to determine the absolute to determine the absolute and also related humidity of air. This method is more practical approach, okay, and we can use a thermometer whose bulb is covered with a cotton wick saturated with water, and to blow air over the wick, so as shown in next slide. Okay, like this. Okay, I show the next slide. Okay, this is what I mentioned. Okay, and this actually this actually called as a wet bulb temperature, and commonly these devices commonly used in the air conditioning applications. So what is a wet bulb temperature? Denoted by TWB. Okay, actually this is measure the temperature while taking into the account evaporators uh, lower than the dry bulb temperature, but higher than the dew point temperature. Okay, so it depends on the humidity of the air. So an ordinary liquid in glass thermometer whose bulb is enclosed by with moisture with water. Another is a dry bulb temperature. Dry bulb temperature is actually referred to the simply to the temperature that would be measured by a thermocouple. That means atmospheric temperature. For air water vapor mixture at atmospheric pressure is approximately equal, okay, to the adiabatic saturation temperature. That is a difference between the wet bulb temperature and also the dry bulb temperature. Others methods for measure humidity is by using aspirating psychrometer, and also sling psychrometer. Okay. Okay. The sling psychrometer uh, actually is the device that have two thermometer. The the first one is wet bulb thermometer, and beside of wet bulb thermometer is the dry bulb thermometer. Let's look on the examples to make you more understanding of this wet bulb, dry bulb temperatures, and also how we want to understand about adiabatic saturation temperature. Okay, the dry and wet bulb temperatures of atmospheric air at 1 atm pressure are measured using sling psychrometer and determined to be 25 degrees Celsius and 15 degrees Celsius respectively. Determine A. Specific humidity, B. Relative humidity, and C. The enthalpy of the air. Okay, based on the equations that I have mentioned earlier in the last lecture, and also in the previous slide, the specific humidity, we can use these equations to find. So before you can use this equation, you have to find the omega 2. Okay, Cp we know for this ideal gas. T2, T1 has been given. T2 is temperature at the wet bulb temperature. T1 is a dry bulb temperatures. So where omega 2, to find omega 2, we can use the equations of 0.622 Pg2 over P2 minus Pg2. Okay, and then put all the values that you can find here, because Pg2 actually we can get from the uh, table A4 properties table. Okay, because Pg2 is the saturated pressure water. Okay, saturated pressure water at 15 degrees Celsius, and P2 is the total pressure. So omega 2 will become 0.01065 kilogram H2O per kilogram dry air. So using this value of omega 2, uh, at the end you will get omega 1 is equals to 0.00653. Okay, this is the specific humidity. B, the relative humidity. Using the equations, Phi1 is equals to omega 1 P2 over 0.622 plus omega 1 Pg1. So put all the values, and then you will get the relative humidity is 33.2%. Okay, and see the enthalpy of the air per unit mass. You can also find it using the equations H1 is equals to HA1 plus omega 1 HV1. So this is the formula for HCPT1. So substituting the values in these equations, then we get H1 is 41.8 kilojoule per kilogram dry air. Okay, now let's look on the psychrometric chart. Okay, psychrometric chart is to present moist air properties in a convenient form. So this is the general basic uh, schematic of the psychrometric chart. As you see here, the dry bulb temperature are shown on the horizontal axis, okay, axis, and the specific humidity is shown on the vertical axis. Here, when you look on the left end of the chart, there is a curve called saturated line, okay, instead of a straight line. All the saturated air states are located on this curve. So it is also the curve of 100% relative humidity. Another constant relative humidity curve have the same general shape. Instead of that, a line of constant wet bulb temperature have a downhill appearance to the right. So line of the constant specific volume look similar except they are steeper. So line of constant enthalpy is very near parallel to the line of constant wet bulb temperature. Therefore, these constant wet bulb temperature lines are used as constant enthalpy line in the same chart. For saturated air, the dry bulb, wet bulb, and also the dew point temperatures are identical. The dew point temperature of atmospheric air at any point of the chart can be determined by drawing a horizontal line um, from the point to the saturated line. So the temperature value at the intersection point is the dew point temperature. So when you draw these all three lines, so the intersection is a dew point temperature. Okay, this is the schematic charts, the real schematic charts. Okay, you have to understand which locations of the what I have mentioned. Example, dew point temperatures, and also the dry bulb temperatures, and so on. Right? Okay, in here at dot line temperature wet bulb, and this is the specific enthalpy, and this line is the specific volume, and saturated. It also has a saturated line and the relative humidity. Okay. Okay. To understand more clearly on psychometric chart, I will show you one of the slide that show how to read a psychometric chart uh, by Rodonic. Okay, this slide I refer to two of the experts that has presented at the webinar. Okay, the author that present this webinar is Bruce McDonfie and Michelle Brooks. Okay, okay, I refer this their slide, and okay, this is the psychrometric chart. Okay, the parameters or the properties that have in this psychrometric chart is dry bulb temperature, humidity ratio, saturation curve, relative humidity, dew point temperature, vapor pressure, enthalpy, wet bulb temperature, and specific volume. That means dry air. Okay, this is the chart of the sclerometric. So when we refer to dry bulb temperature, okay, dry bulb temperature, it is at the bottom of the chart. Okay, this at the highlight. This is a dry bulb temperature uh, scale. Number two is humidity ratio. Okay, at this vertical axis, this is the humidity ratio. Number three is the saturation curve, 100% relative humidity. Okay, these are the numbers that shows the saturation curve. Okay, here. Number four parameters is a relative humidity. Relative humidity, these all the values of a relative humidity. Okay, it have a curve line, 1, 2, 3, and etc. Okay. Number five is a dew point temperature. Dew point temperature, the axis is at the outside of the chart. This is a dew point temperature scale. Number six parameter is vapor pressure. Vapor pressure also at the outside of the chart, at the right side. Okay, this is scale of its vapor pressure. Number seven is enthalpy. Enthalpy is the line. Okay, is the line downhill. This is the values of the enthalpy, also at the bottom of the chart and also at the outside of at the right side of the chart. Okay, this is enthalpy. Number eight is a wet bulb temperature. Okay, wet bulb temperature is at this side. Okay, wet bulb temperature. This one 75, 78, 18, 19. All line. This line is the wet bulb temperature. And the last one is specific volume. Okay, dry air. Okay, this is a line of a specific volume. Okay, here, and it's all parallel. Okay, parallel line here, 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 and there. Okay, that is a specific volume. So to understand more on this, let's see the example of the psychrometric chart. Example number 4. Okay, consider a room that contains air at 1 atm, 35 degrees Celsius, and 14% relative humidity. Using a psychrometric chart, determine A. Specific humidity, B, the enthalpy, C, the wet bulb temperature, D, the dew point temperature, and E, the specific volume of the air. Okay, so when you want to solve these examples, the solution is firstly you look what have been given. So the relative humidity of the air in the room is given. So five parameters that you have to find to be determined using a psychrometric chart. At a given total pressure, that means the state of the atmosphere air is completely specified by two independent properties, such as dry bulb temperature and the relative humidity. And other parameters are determined by directly reading their values at the specific state. So the A, the humidity, the specific humidity. Okay, this is the solutions. Okay, when you look at the properties or on the psychrometric chart, the specific humidity is determined by drawing, that means by drawing a horizontal line from the specific state to the right until it intersect with a w omega at this okay. So firstly, you know what has been given. There are two parameters that have been given. 35 degrees Celsius, that means dry air. This is for the dry air, 35 degrees Celsius here. And then another one is the relative humidity. Okay, phi, that means 40%, that has been given. So the intersection, okay, intersect between these two parameters, you draw the line, the straight line here, you will get two parameters. That means T, dry temperature, dew point, and also the humidity. Okay, so the specific humidity. Okay, okay, this is the chart. Okay, this is the intersection. So I draw the line, the straight line here. So in this circle, it show the dew point, the temperature of dew point. And at this circle, it show the omega, that's means specific humidity. So the specific humidity is in the unit of gram of moisture per kilogram uh, kilogram water, okay, of dry air. So this is a gram. So what have you to do when you see here, this is about the value is about 14.2. So you have to divide it by 1000 to make it the unit kilogram water per kilogram dry water. Okay, kilogram dry air. So by divided by 1000, you will get the answer uh, about 0.0142, okay, kilogram. So this one is kilogram water vapor per kilogram dry air. For the dp, okay, for the dp, it's about 19.4. So how you want to get 19.4? Okay, 19.4, when you see, this is the uh, dew point, okay, Celsius. This is 20 Celsius. So below than 20 Celsius is about 19.4 degrees. Okay. of temperature dp. Okay, then from in this intersection we also can draw the line here, and then at this cycle it shows the enthalpy. Okay, enthalpy. So for this enthalpy, the value is about 71.5 kilojoule per kilogram dry air. Okay, enthalpy. And then for the wet bulb temperature, so we can determine it by drawing a line parallel to the TWB constant line. Okay, so the wet bulb is about 24. Okay, 24 degrees Celsius. This is a wet bulb. Okay, temperature of the wet bulb. So when you see in the chart, this is 24. Okay, 24 degrees Celsius for the wet bulb temperature. And lastly, the specific volume per unit mass of dry air is determined uh, uh, by noting the distance between the specific state and the volume constant line on both sides of the point. So how you want to get this specific volume per unit mass? Okay, specific volume per unit mass actually is at this side. Okay, when you draw this line, this is a specific volume per unit mass. Okay, specific volume. It is between these two lines. Okay, because this black line here and here, this is a volume per unit mass. So here show about 84. This one point 90 90 increase. Okay, here is point 090. Here is point 88 specific volume. So this is the line of the volume, because the intersect of this specific dry air and also uh, relative humidity. Okay, so when you compare in between these two lines, it gives the value of volume is 0.893 meter cube per kg dry air. Okay, okay, this is how you find all the values or parameters that have in the Psychrometric chart. Okay, so to make it more understanding, then you have to do more exercise. Okay, okay, I think that's all for today. Two objective we have covered in this lecture. So see you in next class. Okay, that's all, guys. Thank you for watching, and please do exercise and read books. Assalamualaikum warahmatullahi wabarakatuh, and salam sejahtera.